Hi everyone. Today we will be looking at the Omron PLC Node-RED serial communication. Now PLC manufacturers have their own proprietary protocols. These methods of communication will allow you to program the controller. Other protocols will allow you to collect and log information for programmable logic controllers. Node-RED has the ability to read and write to the Omron controller using some of these special protocol commands. And we will be connecting the Node-RED to the Omron CP1H PLC. A serial RS-485 interface will be used for communication to the industrial controller. We will be demonstrating reading and writing using hostlink or C-mode commands to the Omron. So detailed information contained in the video can be found at accautomation.ca. The link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. Now C-mode commands are specialized Omron hostlink commands. They are issued by a host computer and sent to the CPU unit, and the devices can be connected for serial communications are the CPU unit, a serial communications unit, and a serial communication board. Now C-mode or hostlink commands form a command response system for serial communications. So the hostlink mode to perform various control operations between a CPU unit and a host computer directly connected to it. Now these operations include reading from and writing to I/O, memory, changing operation modes, executing force set and reset operations, and so on. Now there are two hostlink formats, and that's the one-to-N, so one-to-many. So you'd have one host computer talking to several different devices, or one-to-one hostlink. And usually that's not as common, but it's used for things like HMI. And each hostlink unit is assigned a unit number from 0 to 31. So let's take a look at the command response formats that we will see here with our C-mode hostlink. So what's being sent out is this @ sign, and then the unit number, then our header code, which represents the specialized character that we want to do, or the operation we want to do within that remote unit. Then the text associated with that unit. Then we have a checksum calculation to ensure that the integrity of the data is still there. Then we have a termination, which is an asterisk and carriage return. What we get back, or the response frame, looks like this. It has the @ the unit number again, where we sent it from, the header code, what we're doing, the encode, whether so this is the operation, whether or not it was a valid statement or not, or the status or the error code coming in. Then we have our text that we've requested, and then we have our checksum calculation again with a termination, which is the asterisk carriage return. Now if an error occurs, what we will get is the @ sign, unit number, header code, and then the error code that comes in here again, then their checksum and asterisk termination. So here is the list of some of the commands that we can use, and that's the 2-digit codes that we have. And this is only a partial list of what the Omron can get in and out of that controller. And for our complete list, what we will see is that we have a manual here, communication commands, and this is your reference manual that will also go through your C-code, C-mode codes or command codes, which is hostlink, or it goes through your fins command, which is the other option that you can use using Ethernet. So the next thing we'll do is take a look at our option board that we're going to be using, which is going to be a RS-485 connection. And by the way, here is the error codes that we come back with. So if everything's normal, you'll come back with an error code of 00. If not, we have several different error codes that can come back, and that lead you to determine what to do next. So here is our unit that we have here which is our CP1W-CIF11. It's an RS422 or 485 option board that fits right on the CP1H Omron controller. And you'll see here that we have our communication light, then we have our terminal strip here. Then on the back of the unit we actually have our dip switch settings that we have. And those dip switch settings, because we're going to be using RS485, we're going to leave the terminator off because we don't have a long run. This would be used for if you have multiple ones. The last device on your network would actually have a terminator. Then we have a 2-wire system, so number 2 and number 3 are on. Number 4 is not used, so anything not used is off. Number 5 is on to RS control enabled, and number 6 is on RS control enabled. So those 2 are on. So this is the picture of what we're actually doing within our controller. Next, what we have is we are going to use a Waveshare USB to serial port. So what we're going to do is plug this into our computer and our other end here, and we've covered this device before, so we'll have links in this description to show you how to install that and get you up and running and determine your communication port that you're going to have on that. Next, what we'll do is take a look at the Omron program itself. Now the Omron program is going to be very simple, and what we're going to do is just use the LED display on our CP1H CPU, and we'll take D0 or D1, the memory area, and we're going to write it into our LED or 7-segment LED on the CPU itself. And I've got the display here of my first 10 units here, because we are going to be reading these data memories, and then we're going to be writing this one data memory to show that we can do that with using Node-RED. So also, while we're here in the program, what we have to do is set up our communication port. So if we look at our program here, and if we go main menu, PLC, edit, and then look for settings. Right. Let me just look on here, PLC, edit, and then settings. What you'll see here is that we can go onto our startup, and under our startup we want to make sure that we have our mode selected for monitor. Now the Omron PLC is very unique in terms of when you write something to this controller using the hostlink mode, you must be a monitor. This also applies in fins as well. So again, you must be in monitor mode, so we set this so that our initial setting is going to be monitor mode. Then we can go over to our serial port, and our serial port here, we're going to set up for just a standard communication, which is 9600 baud, 1 start bit, 7 data bits, 2 stop bits, and even parity. So that's the standard right across the Omron line of controllers. And our mode will be hostlink, which is selected right here. These are all default standards or default settings, and our unit number here is 0. And again, we can set from 0 to 31 depending on how many devices we want on this network. So we must remember that when we go into our Node-RED programming. So let's go do that now, and we'll go to Node-RED here. So the first thing we need to do is we need to bring in a couple of different modules. So we'll go to Manage Palette, and under Manage Palette, what we will see is we'll go down here, and what we have to use is the Node-RED Omron PLC, which is right here. Currently this is version 1.02, and it brings in 3 nodes, and you can see here that we have it in use, so it's already been installed on our system right now. Then we also have what we need is the serial port. So Node-RED node serial port, we bring that in right here, and that includes 4 different nodes. So again, we currently have it in use because we actually have this program. So they're the 2 different structures that we'll need in our program. So looking at the program itself, you can see we have a timestamp, and all it does is allow us to signal that this is what we want to do now. Then you see those nodes that we brought in, which is the PLC communication. We have a Omron command, we have an Omron receive, and we have an Omron receive all. So the first one we have is an Omron command, and this is the command itself. So we have host link number 0, we have the read, or the RD, which means read data memory. Our beginning word will be 0, and the number of words will be 10. So we are reading 10 data memory words starting at 0. So we're going to be DM0 to DM9. So that is what that instruction will do. Then what we do is we do a message payload to show you that command going out of that instruction. And then we go into our communication. Now our communication instructions here, the ones that we just brought in, we have serial in, serial out, and serial request. And this is the serial request that we want because we're sending out and receiving back into Node-RED. So looking at the serial communication, you can see our particular case, our Waveshare USB converter is using COM number 5, and it's set for 9600 7 even 2, which is the exact same as what our Omron controller was set for that we just did. Then we can look at the actual serial port parameters, and here's serial port number 5. And if you're unsure, we can just take a look, and you see there's only one COM port available to us right now on this computer. Then we have our baud rate, 9600, 7 data bits, even parity, 2 stop bits. Now our start bits are automatically set as a default of 1, so we don't have to worry about that. Then for our input side, we could put in a character to look for and to determine what's the end of that character string coming back in. Or in our case here, what we're doing is waiting 50 seconds when we don't see anything. And we're going to deliver this in ASCII strings, which is what hostlink command is. It's all ASCII, or American Standard Code for Information Interchange. So it's coming back in after 50 milliseconds of not receiving anything. It says I've got all my characters in, so I can bring it out. And there's no special output here. So that is how our serial request is working within our flow. Then what we'll do is, after we have that, we'll message this. So this is our receiving from our communication. Then we will use the Omron receive all. And the Omron receive all command, you'll see that it really doesn't do anything. There's no parameters here. We can give it a name if we wanted to. But what it actually does, it will strip off all of those header codes and the response codes and just bring in the raw ASCII for us, so that we can only deal with, or what we have to deal with is just the ASCII. Then we have our display of what that message code will be. Then we have our function key. So what our function key will do is, because it's just one complete string, we're going to use that string and put it into a variable string for us, so we can use it elsewhere in our program. So that just shows you how to do that and put it into this variable array so that we can use it elsewhere in our flow. And we have covered saving it to a database, so we can save this information to a SQL database on our network. We can also use it to look at a user interface using Node-RED. Again, the links to this is all described below. And then finally, after our function, we'll show you what that array looks like. So that is our serial read. Now, a serial write, we'll look at that after we look at the hardware that we have here. So what we'll do is just call up the hardware. And here we go. So here is our CPU unit. Here's my CP1H. And we are currently communicating through a USB port here. And there is our communication module attached to the first slot here. You can see that I have my LED display here. It's currently at 00. And from my communication module here, we're using the first two here. We have RDA negative and RDB positive. So the positive goes to positive on our Waveshare converter, and the negative will go to the negative. Then this just communicates back to our USB to our computer that we're using. So that is the communication that we have. So now let's take a look at, we'll just open this up a little bit more here, and let's try this out. And what we'll do is do the Omron read. So there we go. So this first read here, and you'll notice as I highlight it, it actually shows that coming from the message payload to show us that out of the command response, this is the command we're getting. So you see 00, which is our unit address, read data memory, the first data memory, which is 0000, and we're going to read 10, which is 0010. So, and then our checksum and our termination is the asterisk carriage return. What's then received under our serial, so it goes out to the serial port, comes back in again, and we get this at 00 RD00, which means that it is read successfully. It's normal operation. And then we have our data starting with the first D0, which contains the value 1197. And then we have all the consecutive memory areas coming back in 4-digit or ASCII character blocks. Then next what we have is, after we have that coming back, we use the Omron receive all, and it basically strips that out and only leaves us with that value from 1 over. You see it strips out this and strips off our checksum calculation and carriage return at the end. So we have this one complete string. Then we use our function key, or a function node, and we convert that into our array structure. And here's our array, and they're the values from D0 to D9. So that looks like it's working well. Next, what we'll do is take a look at our write instruction. And on our write instruction, again, timestamp just to signify that we are going to be writing out this. Then our command structure again. Let me just close this off. So we're going to go back to 00. We're going to write to the data memory. Our beginning word will be 1, and we're going to write the number of words. We're going to write 0 to that data memory 1. Okay. So that is what that statement says. So let's just change that, and we can change that to the value. We'll go FF, and we'll just hit done, and then we'll deploy that. So now we're changing it to FF, so that means our LED display on our CPU now will change to FF, just to show that it's working. Then what we do is we will show, using the message payload, what's actually being sent out. Then we use our serial request, and that serial request actually is still using the same COM5 9600 7 even 2. So that automatically gets out, and the same parameters will apply as before for our communication port. Then we have our message payload of what's actually coming back, which would be just the value saying that we've done that right. So let's take a look here at the information coming back. We will inject this, and you can see here what we got going out is 00. So write data memory 0001, so the first memory area, and we're writing 00FF, and that's a checksum carried return. What's coming back here is 00 write data memory 00. So remember that we had it in monitor mode, so that's the only way a write will work within the Omron controller. And then our checksum termination again. And you can see by our screen here that we have the value now FF being shown on our display screen. And let's just change this now to, we'll say 11, make it a little easier to read. And we'll deploy that. We'll do a write again, and we'll inject it. And what you'll notice is that now we've changed to 11. So very easy to implement the Omron host link or C code commands. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.